Okay, example number 7 is similar to yours. We've got a particle, it's got a force of 4 newtons pushing it up. Its weight's 2 kilograms, it asks us to find the acceleration. The key difference is here, it says that tan alpha is 3/4, and they don't want to find the value of alpha here. What they want you to do is use a right angle triangle to say that, well, tan alpha is equal to opposite over adjacent, sorry. So therefore it's a 3 for the opposite and a 4 for the adjacent, which then allows us to use Pythagoras. 3 squared plus 4 squared is 5 squared to get 5 for the hypotenuse. That then allows us to write down that sine alpha is opposite over hypotenuse, 3/5, and cos alpha is 4/5. Right, they might come to a situation where they use, say, an algebraic letter in this or something, so that you can't actually do it using any other method. But actually, it turns out that this is quite easy once you get used to it. It's easier than messing around with long decimal points. It's much nicer, it's much cleaner. The other rule we're going to need to use is one rule that you might not remember. It's that sine 90 minus alpha is the same as cos alpha, and vice versa, cos 90 minus alpha is the same as sine alpha. Right, so we're going to use that in this question today as well. And actually, all the way through mechanics, we're going to see questions that involve being given a value of tan alpha and having to work out everything else from there. Alright, so you will get used to this, you'll get used to using these formulas and substituting in as we go through. So the first thing we're going to do, the question doesn't actually ask us to find the reaction force, R, but I'm going to do it just because it's important for the exercises and going forward in other lessons. So let's firstly look at the reaction, even though the question doesn't require that. So for that reaction, we know it's not taking off, there's no movement in that direction, so the forces have to balance in that perpendicular direction. So the reaction is equal to, and here we've got the 2G force, but it's not the 2G force as it is, because the 2G force is straight down, and you can see this dotted line is the perpendicular direction that we're resolving along. So to move from the 2G to the dotted line, right, we would go away from my angle of 90 minus theta, and if we're going away, it's sine of that angle. Then we change that using our formula down here to be cos alpha, right, 90 minus alpha is the same as cos alpha, and then we multiply 2 times 9.8 times 4/5, just substituting in from my cos alpha value there, and this will give you 2 times 9.8 times 4/5 is 15.7 newtons to 3 significant figures. To find the acceleration of the particle, we are going to resolve in the direction of the slope, right? And generally we would try and resolve in the direction that we think the particle is moving, to take that as the positive direction. But in this case we don't really know, because we've got the weight pulling it down of 2G and we've got a force pushing it up of 4 newtons. So we don't know which force is bigger. So I'm just going to say that that is positive. And if we end up getting a positive force when we resolve in that direction, then that will mean it's moving up the slope. And if we end up getting a negative force, that will mean it's moving down the slope. Right, so even though we don't know, we can see from the sign when we do the forces which way it's going to be accelerating. So if we're taking up as positive, it's 4 in the positive direction, 4 straight up. We don't have to do anything with angles because it's already moving in that exact direction. And then down the slope is our 2G, but we've got to use, we've got the 90 minus alpha, we've gone through the 90 minus alpha to get to the slope. So it's cos of 90 minus alpha. Using our pink rule from over here, that's the same as sine alpha. So this is 4 minus 2G sine alpha, which again is the same as 4 minus 2G times 3/5. And if we put that into our calculator, we've got the sine alpha from over here, right, 3/5 sine alpha. Put that into our calculator, we will get a value of minus 7.76 newtons. Right, that tells us it's a negative force, so the force pulling it down is bigger than one pushing it up, so the acceleration is going to be down the slope because we took the positive direction as up the slope. Right, so that's what I'm saying, we've got a negative force, so we'll be moving down the slope. So now what I'm going to do is do my F equals MA, which is minus 7.76 equals 2A, then I divide by 2, and I get minus 3.88 meters per second squared. And again, that acceleration is negative because if the force down the slope if the force is going to be negative, so we're moving down the slope, that means the acceleration will be obviously down the slope, so negative as well. And I'm just going to pop in a little concluding line that we will be accelerating down the slope at 3.8 meters per second squared. Okay, so that's the last example from that, example 7. All we're going to do with that now is we're going to have a look at the exercises. It's exercise 5b, and there are 8 questions, so I advise you to do the odds only first, and if you need more practice you can go back and do the evens.